Jeff asked me to talk here about quality, which of course I did 7 years ago. And I'm really grateful for that because I think one really important component, the most important component for delivering great quality is the culture of your organization. And the fact that Jeff asked me to talk about quality in this event, that's part of the culture of quality right there, because culture is all about what do you talk about? What do you focus on? How do you make trade-offs? What do you ask your team to think about? How do you guide others in making trade-offs? What kinds of behavior give rise to bonuses and celebration? And at Arista, we are 100% consistent on this. Quality is the most important thing. All the whiz-bang features you might hear about from other vendors, or from us for that matter, don't mean a thing if the network is down. So that's why we spend so much of our time and energy thinking about this, working on this, and here, talking about it. I love questions, so please, the more interactive this is, just jump right in, interrupt. The more it's a conversation, the better it is, okay? And the other reason why I'm glad to talk about quality here is, as we've already mentioned, we gave, I think, a pretty nice presentation on this 7 years ago. But I wanted to talk a little bit about what we've learned over the last 7 years, how things have changed and evolved, how you stay true to that mission, true to that vision, that value. The quality is the most important thing when you scale your organization to 1,500 engineers, where you have use cases across all domains of your network, from campus to the cloud, to the WAN, your data center interconnect, data center edge, down to the spine and the racks, the whole thing, right? And so the great expansion in our product portfolio, our feature set, and how do you maintain quality through all of that? So those were the two things I wanted to talk about here. So let me start with the fundamentals, quality being the most important thing, culture of quality. What does that mean in practice? How do we put that into motion? Actually, let me back up one step. I talk a lot about this. I assert to you that our quality, as Jeff put on his slide, it's an order of magnitude better than our competitors. Not 10% better or even 50% better. It's more like 90% better. That's a pretty bold claim. I better have some evidence to back that up. Well, you know what I wish I had? I wish I had a neutral third-party organization whose job was to catalog and categorize all of the software defects in network gear that bring down people's networks, that disrupt their applications, could rate them on a scale of 1 to 10, and you could see this sort of apples to apples across vendors. I think that would be a wonderful thing for the industry to have. We don't have that. But the next best thing we have is the Common Vulnerabilities and Exposures Database, CVE. And now look, I understand that not every bug is a security vulnerability, but remember, every security vulnerability is a bug. And the same questionable engineering practices and sort of poorly applied focus that leads to so many security vulnerabilities in our competitors' products also leads to bugs of other types. So I invite you to do your own Google search, CVE Arista, CVE EOS, and compare the numbers you see there to CVE with any of our competitors or competitive operating systems. I think you'll see a sort of a 10x plus difference, which, by the way, is good just from a security point of view. I mean, who needs hundreds of security vulnerabilities in your products and doing emergency upgrades once a week? I honestly don't know how customers deal with the sheer quantity of those kinds of problems that come from our competitors. But I also think it's a larger indicator of quality.
I would say, like, Arista has a smaller profile, a smaller portfolio than some of your competitors have. And I've not looked at the numbers, but like, if you stick within similar products that you have to competitors, that number still holds true, or that factor holds true?
Yeah, absolutely. So again, I invite you to do your own search along these lines. I would point out that our competitors have splintered their operating systems across use cases. So it's actually not really true. If you look at EOS as an operating system, it addresses actually more use cases than any one of our competitors' operating systems, if you know what I mean. And then the other comment I make here is our market share is not small anymore. We're probably around 20% of the data center. Our next biggest competitor is maybe roughly 2x that. So we're getting up there in terms of our footprint and our market reach. So I think the CVEs are one way. And the other reason I believe that we have better quality is from talking to customers and just hearing about their experience. And every customer I talk to tells me how much they appreciate being able to count on their network. They just don't worry about it anymore. It's like they were so afraid to even touch it before because every time they touch it, something would break. And that's no longer the case. And it just changes the way they feel about their life. And so it's I certainly invite all those of you who have friends using our products to ask them about that. And some of our competitors, by the way, are very quantitative and look at the number of sort of outages per device operational hour of us compared to competitors. And they tell me the same thing. Unfortunately, I can't share this data, but it's around 10x fewer problems per device operational hour than what they see with our competitors. So I'm firmly convinced of this, but I invite for you to talk to your friends and see if they would agree. Now, how do we get there? And you get there, there's three things you need to do to get better quality. And the first is software architecture. EOS has a better architecture than our competitors. I'm going to leave it there. I don't have time. Plus, this is a great topic for a room full of software engineers. And I, by the way, invite that because I love talking about the software too. But software architecture, a good architecture means that common programming errors lead to transparent restarts and not network disruption. So that's what we've achieved there. But that's all I'll say about that. Number two is how you test. We've made a tremendous investment in autonomous testing. Over 2,000 test beds, 6.5+ megawatts of data center capacity, dedicated to running hundreds of thousands of test cases, I think 350,000 or something, test cases, 24/7, fully autonomous, meaning zero human interaction. Software decides which branch of the code to build. Software then runs all the unit tests, which are hundreds of thousands more tests, as part of the build process. If the unit tests all pass, then software decides which of our 2,000+ test beds to load that image onto, and then which tests to run based on a database of test priorities and past results. We run the tests, software records the results in the database. Again, no person is involved here, right? We can all be on vacation in Hawaii and we'll go on testing our switches, right? If the test passes, that's great. If the test fails, software matches the log of the failed test against fingerprints of known bugs. There's a match, software annotates the bug. Mr. Engineer, happened again, right over there, better come take a look, right? If there's no match, then the log goes onto a queue of unexplained test failures, where an outsourced group spends all day, pluck a log off that queue, read the log, try to understand what's distinctive about the log. If the test were to fail again in the same way, how would you know? And then they open a bug, create a new fingerprint to map the failed test run to that bug, and go on to the next unexplained failure. And with this apparatus, we're able to run every test case for every product feature on every software release, on every hardware platform. That includes all of our maintenance releases. I sometimes feel like our tests, that sort of massive test code, might be the most valuable piece of intellectual property that Arista has. Because I can take a switch, put it into a rack, and tell you in 2 days if the switch works. I don't think any of my competitors can do that. And that's just long-term competitive differentiation right there. So with all these tests, I wish I could look you in the eye and say we have 0 bugs, but it's not true. And every time we add new features, every time we add support for new platforms, we add new bugs, including in stuff that used to work. And this drives me crazy. And so I tried to look at like, what does it take to get to 0 day 1 bugs? And I go through these cases and well, okay, now that I know it's wrong, I know what test to add, but how would you ever think of that? And I went and read some studies by a guy named Jim Gray, who's an old school software fault tolerance guy from Tandem days. And he did some studies on this. And according to his studies, when engineers check in the code and say, yeah, boss, it's done. I tested it. Yeah, everything's working. There's 1 bug per 10 lines. And once you run it through QA and QA puts that big stamp of approval on it and says quality assured, it's 1 bug per 100 lines. And then once the code's been in the field for 5 or 6 years and they've done all the maintenance work, you're down to about, it's hard to estimate at this point because the bugs are very intermittent and you don't know what's really causing them, but around 1 bug per 1,000 lines. And this study changed the way I think about software. You look out over the cube farm and all the folks are tapping on their keyboards and I just picture the bugs flowing out of their fingers into the code. And so the whole challenge then is how do we keep those bugs out of your network? And that's where the automated tests are a very big part of that. And they've been extremely effective for our maintenance releases. our maintenance releases have essentially zero regressions to first approximation. In hundreds of releases, I'm only aware of 10 times that we broke something in an important way in a maintenance release. And if you take that to heart, what you'll realize about that is that should change the way that you manage your network. That no longer should you take upgrades only because you absolutely have to. If you've already qualified an image, my request to all of the Arista users out there, so part of the operational experience we've gotten over the last 7 years is looked at some good data on what is the nature of bug bytes in the field. How many do we have? What are the nature of the bytes? What versions, what products? What we found is that more than 80% of our bug bytes are bugs that we've already fixed and released the fix in a maintenance release of the train the customer was running at the time of the byte. That means the number one thing I can do, I can reduce my field bug bytes by 80% if I can convince all of you to take my maintenance releases, right? And every time my phone updates itself, I'm just like, why can't I do that? But I won't, I promise. I'm not gonna reach in and like, upgrade the software on your network when you're not looking, although I'm very tempted. I'm not gonna do it. But my request is that you do it. When we've automated this whole thing in Cloud Vision, so you can do this very, very easily in Cloud Vision. If it's my network and my butt's on the line to keep this thing up, and Arista comes out with a maintenance release of the code I'm currently running, I've already qualified. What I'm gonna do is take that release, put it on one switch, watch it for a week. If it looks good, roll it out to a pod, then to a data center over 4 to 6 to 8 weeks, roll it out infrastructure wide. And Cloud Vision can do all this, by the way, with the change controls, the provisioning and device tagging. So you can do this sort of automated rings of upgrade kind of process. And yes.
Question around the testing. It's easy to test installs and upgrades and things like that. Are you including simulated traffic or live traffic in that testing? Because that's where the rubber meets the road, is if it affects actual user traffic going through those systems.
Oh, absolutely. Our auto test framework consists of, it's kind of funny because most people's racks have like a couple of switches at the top and then lots of servers. My racks have a couple of servers at the top and then a lot of switches. Because what we've done is we've wired the switches up in pairs. So there's a sort of wired kind of back to back. And one switch is the sort of device under test running the latest EOS code. The other switch is running a version of EOS in a mode where it's a traffic generator. And so we run traffic of all types, line rate traffic, we do performance measurements, congestion scenarios, as well as running protocols. We test all the routing protocols, layer 2 protocols. We do all of that in our auto test environment. So the customers essentially, when a customer has already certified a release and now they're testing a maintenance follow-on to that, they've literally never found a regression. They have occasionally found bugs, but the bugs are actually also present in the code they already certified. So I really do believe people are wasting their time when they recertify a maintenance release of a release they've already certified in their environment. Another question?
Did you say that the data generation was baked into EOS, or that's what the servers are doing? They're generating?
No, the servers are coordinating. So I've got switches wired back to back, and and EOS is actually generating the traffic. We have a way of running sort of packet generation capabilities in a sort of a mode of EOS.
And I can do that? Or is that something that you guys do internally?
That's something that we do internally. I don't know if the functionality for that is customer visible or can be made customer visible. It's not a product feature we advertise, but
okay.
Yeah. Great. So I guess with my remaining time here, I would talk a little bit about how things have changed as we've tried to expand and particularly as we've been doing acquisitions. Because of the quality principles I've been outlining here, including all of the testing related stuff, is stuff we've been doing since day one. Every piece of EOS, every layer has been built up with those quality principles in mind. Then you go out and acquire a company or two or three, and they come with engineers with their culture and practices, and also with a lot of existing code. So I went into this with a fair amount of trepidation, like how is this gonna go? What's this gonna be like? And the first thing I found was very encouraging, which was you go to a company they've been working their tail off for years, trying to get traction in the market, and just sort of, we build the following 39 features, maybe this big customer will buy. And then, it's just been nothing but panic for so long. And you go to them and say, okay, guys, I know you've been in this very high velocity mode, but we're gonna have to shift this. This is actually gonna have to change. We need you to focus on quality. Quality has to be the highest priority now. And that means, focus on architectural correctness, on the testing and test automation, on delivering tests along with the new, all the kind of practices. And the reaction from the engineering team is, oh, thank God, right? This is what, as engineers, they always wanted to do, but didn't have the charter. They didn't have license. They were being constantly told by their management and by their leadership, no, the priority is speed. If we don't get this feature to market by this time, we're gonna run out of money and you're not gonna have a job. All your options are gonna be worthless. Is that what you want? Okay, so go build the extra 39 features. And it's just been in this mode for so long. And so the engineering reaction is like, this is like a dream come true, basically. So in terms of like convincing engineers that we ought to do this, like that is like not a problem at all. Getting it to actually happen, that's more challenging. Because when you've been doing this from your earliest days, you had no features. You had no existing code. And every layer of your system was created with the need to test it in an autonomous fashion firmly in mind. The hardware folks figured this out years ago. It's even got an acronym like everything in hardware land, right? DFT, Design for Test. There are a whole bunch of rules and guidelines and steps that hardware engineers take when building their boards to make them easier to test. They put little header pins in the right places. They put the heat sinks mounted in a certain way so they can still get at the chips with an in-circuit tester. There's like a whole bunch of things like that. I'm not a hardware guy, but like in the software side, how often do you talk about this? How often do you hear software engineers talking about how they build their code differently to make it easier to test? And the answer is never. And I hadn't even realized how much of that we were doing at Arista, how much people's designs and implementation were influenced by the knowledge they had going into it that, oh yeah, and I'm gonna have to write a bunch of tests for this. So you've got test knobs in the right places. You've got the code factored so that the part that's like actually fiddling with hardware registers has been separated from the part which is like the logical state processing on top of the hardware state, right? But the acquisitions haven't been doing those things. And so in addition, there's no frameworks, there's no patterns to follow. We established those patterns when we were a very small company, but you've got a big existing code base, you don't have those patterns established. You don't have examples to look at for how you test different kinds of things. And so it's been a journey, I'll say, to get to the point where on our acquisitions, we have now I'm not sure how specific to be here, but I think we have in one of our acquisitions, more than 80 product tests, which is not a very large number, but it's enough that you've got a bunch of good examples. And we have the commitment from the engineering team. So part of the culture of quality is committing to building the tests along with the code. And that's both true for building new features, but it's also importantly true when you're dealing with escapes. When something bad does get out, what's the engineer's job? Number one, get the customer back on the air, right? That's the highest priority. Figure out what's going wrong to the point where it can stabilize that network. Number two, get to the root cause of the bug. What's wrong with the software that caused this to happen? What's step three? It's not to fix the bug. It's create a new test. I want a test that exposes that root cause. Run that test and demonstrate that it fails. And then we can smile and nod and go on to step four, which is to actually fix the bug. And now your test passes, and now you can check this all in, and you know that bug is never going to come back. So it's getting those processes in place. But I think we've made some very good progress. It's been slower than I hoped in terms of getting everyone sort of consistently doing this. But slow and steady wins this race. That ongoing commitment, that continual reinforcement is the path to getting to a higher level of software maturity, a higher level of software quality, and to maintain the promise that I'm making to you today, which is that quality is our highest priority. It will always be our highest priority. Quality is more important than features, more important than platforms, more important than hitting our schedules, because I would rather apologize 100 times to each of you for not having some feature you want, for not having some hardware platform that would be useful to you, than apologize even once for melting down your network and screwing up your applications. because networks are just too important.
I really appreciate how passionate you are about this. And I know how deep it runs at Arista. There was a point where I was interviewing for a position there.
All right.
And I had two people bring that in as part of the interview process, talking about the quality. So it's really good to not hear it from somebody as high up in the company as you are, and know that it's deeply in your company's culture to where they're talking about it on recruiting calls.
Well, thank you very much for that. I appreciate it.
From a developer, you get 10 lines of code or one bug per 10 lines and all that.
In the study, just to be clear, that's not my own data, but
Right.
from, yeah.
Do you guys have data for where you sit if you use that as a benchmark?
I do not have that data, actually. I found this whole area, so customers ask for this, right? They ask for quantitative metrics of how many bugs. And the problem with this is that counting bugs sounds easy, but it's not. And so we haven't made the investment to really be able to kind of cogently count that to the point where we have numbers that we can meaningfully compare across groups, across areas, across time. So what we focus on instead is the customer experience. What are the customers actually hitting? What is the tax saying? And I'll tell you something, we've got the happiest account teams of any vendor because they can spend their time selling instead of apologizing. And there is nothing, like account managers, it turns out people often think incorrectly that what account managers care about the most is making their numbers and getting their bonus. They like getting their bonus, okay? That is absolutely true. But there's actually something which is more important to them, which is their relationship with their customer. That's more important than their quarter. It's more important than their relationship with their employer, because employers and quarters come and go, but customer relationships are forever. And nothing fouls up a customer relationship faster than delivering a product that doesn't work. And so no one is happier than Arista account managers. And as long as that's the case, I'm happy.